Hi all, and thank you for attending my talk. My name is Marija Selaković and I work as a developer advocate at Crate.io, a company that has been developing CrateDB database for the last 8 years. Today I'm going to present you some interesting stuff about CrateDB, and as title suggests, we will discuss whether CrateDB is a database or a search engine. And I will show you how it combines the best of both. If you have any questions after the talk, please be free to post it in Q&A chat function or just send me the email. I'm looking forward to your questions. This is the agenda for today. It looks relatively simple, but it's full of interesting details. In my talk, I will first introduce CrateDB database and give you some general overview. Then I will shortly discuss its architecture and some of the latest features, such as logical replication. Then we will see how easy it is to run CrateDB, and we will do a small demo with a dataset. Finally, I will discuss when to use CrateDB and for which use cases it makes a perfect choice. So now let's start with a general introduction to CrateDB. CrateDB is a distributed, horizontally scaling database for data-intensive analytics solution. It has been in active development since 2014, and it's open sourced under Apache License 2.0. CrateDB is an excellent database solution for event data that are high-volume non-transactional data, for mixed structured and unstructured data, when you need fast analytical queries, and highly scalable deployments. CrateDB is a NoSQL database with SQL interface, and it combines the best of both. It offers PostgreSQL compatible interface for easy data consumption, and tables in CrateDB are represented in a relational format. So to query data in CrateDB, you just need to use standard SQL as a query language. On the other hand, CrateDB provides full flexibility by supporting dynamic objects and schema. The search engine is based on Apache Lucene project, which means that the columns get indexed by default with a low overhead. As a user of CrateDB, you can of course choose to disable indexes. And to achieve high ingestion performance, CrateDB adopts the eventual consistency model. As already mentioned, CrateDB supports PostgreSQL wire protocol, which makes it easy to use many PostgreSQL compatible tools and libraries directly with CrateDB, such as data orchestration tools, for example Apache Airflow, business intelligence and visualization tools, for example Power BI and Apache Superset, IDEs, tools for building ETL pipelines, and many others as illustrated on the slide. Now that you got a very first impression about CrateDB, let's take a look about the main architectural details. The core of CrateDB is a SQL engine that takes care of parsing SQL statements and executing them in the cluster. The image on the right side actually shows the main components of CrateDB node. Client communicates with the CrateDB node through Postgres wire protocol or HTTP endpoint. Then the engine first invokes a parser. Parser breaks down the SQL statement into its components and creates an abstract syntax tree. Then the analyzer performs semantic processing of the statement, which includes verification, type annotation, and normalization. After analyzer, planner builds an execution plan from the analyzed statement and optimizes it if possible. Finally, execution engine executes the plan in the cluster and collects results. It's also important to mention that CrateDB is a shared nothing distributed system, which means that every node is equal and can perform any task. This architectural decision actually enables very easy scaling, automatic data rebalancing, and it makes sure that there is no single point of failure, which is actually a quite good benefit. The next thing I would like to discuss is about storage and indexing. And to be able to retrieve data efficiently and to perform aggregations, CrateDB uses Lucene for indexing and storing data. By default, it indexes all data. Fast search is achieved because the fields of each row are indexed using full text index of BKD trees depending on the field type. So in this example, we can see how the CrateDB creates full text indexes. So it creates full text indexes for 3 terms: almond, milk, and flour, by mapping the term to the document or row ID containing this term. CrateDB also performs fast aggregations, and this is done due to Lucene column store feature, which stores columns separately in order to quickly perform aggregations on them. In our example, from the table on the left side, CrateDB generates 3 column stores. In general, this indexing strategy that is based on a Lucene index enables CrateDB to be very efficient when performing full text search and aggregations. When it comes to the CrateDB architecture, it's also important to briefly mention sharding and partitioning. Every table in CrateDB is split into a configured number of shards, and shards are then distributed across the cluster. As nodes are added to the cluster, CrateDB will move shards around to achieve maximal possible distribution. On the slide, you can see a statement for creating a new table. This table is called metrics, and it's clustered into 3 shards. However, you don't need to know about or to think about shards when querying a table. But sharding is important because it enables read requests to be broken down and executed in parallel across multiple shards on multiple nodes, and this massively improves read performance. When it comes to sharding, it's also important to mention partitioning to further improve query performance. Partitioning can be done on 1 or more columns, and partitioning means that splitting a larger table into smaller chunks, which minimizes the number of records that needs to be queried. And the example on the slide shows a statement that creates a new table and partitions it by derived column called tsmonth. This column is generated by truncating the month value from the timestamp. Each partition can also be distributed on 1 or more shards, and in this example, 3 shards will be used for each partition. However, partitioning may have some disadvantages, especially if the partition columns are badly chosen, so that you end up with too many shards in the cluster, affecting the overall stability and performance negatively. So when sharding and partitioning, you should always think about the balancing, which columns to use for partitioning and how many shards you need your table to be clustered. Now, I would like to move to the next topic, and it's about logical replication. It's a relatively new feature in CrateDB and available since 4.8 version. CrateDB is very important. It's actually a method of data replication across multiple clusters. And in CrateDB, logical replication is implemented with publish-subscribe model. CrateDB uses a publish and subscribe model where subscribers pull data from the publications of the publisher they subscribe to. So, as illustrated, publisher is a database instance that makes data available to other locations through publications. Subscribers are database instances that receive replicated data from one or more publishers. It's also important here to mention that each cluster can have both publications and subscriptions. So now when we understand what is the logical replication, let's see how to actually create publications and subscriptions in CrateDB. The syntax for creating publications and subscriptions is relatively easy. One can create a new publications by specifying the name of the publications and whether the publication contains all tables, subset or tables, or no tables. In CrateDB, all operations or tables are also replicated. This includes insert, delete, and update operations as well as schema changes. For now, no aggregations are possible during replications. And to create a subscription, one must specify the connection to the publisher and the name of the publication to be replicated. Optionally, you can also enable a parameter that specifies whether the subscription should be actively replicated. But replicated data on a subscribers are read-only, and this means that changes are not possible on replicated tables. But this may change in the future, so keep track of changes in CrateDB. Logical replication is a relatively new feature, but it's very important for achieving high availability of CrateDB clusters. And there are several use cases where logical replication is quite important. In this talk, I would focus on two, and the first one is about centralized reporting. Replicating data from a smaller localized cluster back to a central reporting cluster. Using a centralized reporting cluster is useful for consolidating data from multiple geographically distant clusters. In this case, after replication, data can be filtered, aggregated, and prepared for further analytics. Additionally, using a central cluster helps when querying across a large network, which may incur long delays. In the diagram on the slide, you can see that logical replication, actually in this case, is represented by replicating data from 3 clusters in 3 different regions to a central cluster. In this use case, data required for aggregation and analytics can be retrieved closer to where the analysis is taking place, which significantly improves reporting efficiency. The next use case is about improving data locality and reducing latency. This is achieved by replicating data from a large cluster to a smaller localized clusters that are geographically closer to the application servers. This improves the latency and response time as it minimizes the distance between required data and applications. The diagram on this slide illustrates the replication of data from one data center to 3 clusters in 3 different regions. And the additional clusters contain the replication of data required for that particular region. This improves the data locality and reduces the time that application needs to access the data. So this has been the second example of logical replication use case. And with this, I'm finishing my discussion on CrateDB architecture and logical replication. So the next part of this talk is about practical things. I'm going to show you how easy it is to try out CrateDB. So there are many ways to download and start CrateDB, but the quickest way is to download it and run from a tarball using the command that is actually illustrated on this slide. Once the CrateDB is downloaded, it opens an admin UI via localhost and port 4200. Admin UI runs on every CrateDB node and looks like this when it loads. You can use admin UI to inspect and interact with the whole CrateDB cluster. It gives you the overview of your cluster, provides query console, the information about nodes and shards, and possibilities to monitor the cluster performance. So once you have your CrateDB instance up and running, let's see how we can actually use admin UI to manipulate with the data in CrateDB. So now I open the admin UI on localhost port 4200, and it actually gives me the landing page of the admin UI gives me some interesting details. First, it tells me what is the name of the cluster, what is the health of the cluster. Good health means that the data are available and replicated 100%. It tells me how many records are available on this cluster, how many records are under-replicated or unavailable. It also shows me what is the cluster load in the last 1 minute, last 5 minutes, and last 15 minutes. There are also some details that are actually illustrated on this landing page. It also gives me overview of how many queries per second are executed and what is the query speed. And also what is the speed for each type of query, like select queries, insert queries, update, or delete. On the left side, you can see the menu bar, which actually gives you the navigation on admin UI. So you can open, for example, console, which is used for executing SQL statements. There are also a list of tables that are available on this cluster, the list of views. Currently there are no views on my cluster. Shards, how many shards are there for each table. Some further information about the cluster and how many users are actually created on this CrateDB cluster. In my case, there is one super user called Crate, but it's easy actually to add more user and to grant them different privileges. So now let's go to tables. If you click on a table, for example, in this case, the table is called power consumption. It has a good health. It's actually clustered on 4 shards, and there are no unavailable or under-replicated records. I can actually very easily query this table by clicking the button query table, which generates the SQL statement, select statement actually, and limits the select statement to 100 rows. So if I click submit query, I can see that I can see the first 100 rows from this table. I can further filter this table or sort the table on different columns. But what I wanted to show you is that except, you know, like the simple types, you can also store objects in CrateDB. And this metrics table also shows you how the objects can be stored in CrateDB. So if I click query table, I can see that this table looks simpler compared to the previous one, but one of the columns in metrics table is called actually contains objects, and object can actually contain another object. In this case, this is an array, or can contain properties that have primitive types. Objects can be also null, and what is interesting in CrateDB, you can also query objects. For example, I can say select number, name, fields, array, and if I say submit query, then actually this statement returned from each object the array property of that object. So this actually gives you the flexibility to store also object types in CrateDB that may have strict schemas or dynamic schemas. In case of matrix table, object has dynamic schema, which means I can add objects of actually different number of properties. So this is the general introduction to the CrateDB admin UI and how you can use it to execute SQL statements on tables that are actually located on this cluster. So let's go back. Now when you have seen how you can play with data in CrateDB, I actually hope you like it. I would like to mention some of the other features that are supported by CrateDB. I don't have time to go through all of them into details, but it's important to mention that, for example, CrateDB can be used to store and query geographical information. You can also define custom functions for further data processing. So, for example, you can create functions that can be used directly in SQL queries. In backups, in CrateDB are done via snapshots. You can very easily do user management, and you can add different privileges to each users. You can also encrypt internal communication between CrateDB nodes and external communication with HTTP and Postgres clients. We also mentioned dynamic objects during the demo. And for example, you can export data from CrateDB to a file or import data directly to CrateDB from a file. So this is some list of features that is interesting to mention at this point. But if you would like to learn more, I would invite you to check our official documentation and to see actually what you can do with CrateDB. Now I would move to the last topic for today, and it's a very important one. So this topic is about when to use CrateDB and what are the use cases when CrateDB has a significant advantage compared to other database solutions. So first, CrateDB is a good choice when you want or have to use SQL as a query language. It's perfect solution for time series data, large amounts of data, IoT data, real-time analytics, when you have to manage geospatial data, structured and semi-structured data, and when you need high scalability and performance due to thousands of queries per second. However, it's important, really important to mention that CrateDB is not a good choice if you have transactional workloads, when you need or have to use foreign keys, and when your data is highly hierarchical or normalized. So in these three cases, if you have such requirements, CrateDB is not a good choice. But I hope that this actually helped you better understand when makes sense to try out CrateDB and what are the good use cases for CrateDB. Now, when we have seen how easy it is to use CrateDB, let's conclude the talk. We can all agree that having highly scalable data infrastructure is a key for many data-intensive applications. CrateDB is a database solution that makes it simple to store and analyze massive amounts of data. It offers you unlimited scalability, efficient dynamic infrastructure, and flexible dynamic schemas. Due to PostgreSQL compatibility, CrateDB is easy to integrate with existing toolchain. It is fast in aggregation and search and makes it a perfect solution for many data-intensive applications. Last but not least, CrateDB is an open source solution, easy to use, And if you want to learn more about CrateDB, please visit our community website and check about how to use it, check on many interesting tutorials, and check the most typical use cases that we had so far. So with this, I would like to thank you for your attention. I'm looking forward to your questions, and yeah, hopefully to meet you in person at We Are Developers World Congress. Thank you.